So very good day for Dr. Abdul Hashim. So my name is Aiman Daniel bin Abdul Razak with a metric number U2003955/1. So today I would like to present our presentation for KIG2001 from OCC3 with the title of Smart Garage Door System. So this is the list of our group members including their metric numbers. So to start off, garage doors are often used by homeowners when they want to park their car in the garage. This causes an inconvenience for a homeowner as they need to manually open the garage door. With Smart Garage Door, the homeowner doesn't need to come out from their vehicle when they want to park in the garage. So our goal is that we want to create a system where when the car approaching near the garage door will be opened by themselves with the motion sensor that we plan to include near the garage system. So the problem statement for our project is that how to make a garage door open by itself based on the motion made by the vehicle as they approaching near the garage. And also our second problem statement is that how to construct an electrical circuit for smart garage door using Simulink in MATLAB. Our objective with this project is that we want to create a circuit that switch on only when there is a motion detected at the outdoor area of the house. And second, we want to determine and verify the electrical circuit components that can be used in designing smart garage door system.
Hello, my name is Ahmad Aiman Noslan, U200984, and I will continue Aiman Daniel's presentation. This is the proposed circuit for our smart garage door system. We have 10 ohm resistor that is connected to 240 volt DC voltage source, and this circuit is connected to a shunt motor. The shunt motor is to convert the electrical energy to mechanical energy. So how the circuit work? Basically, we have a motion sensor near the DC voltage source that function as a switch in our circuit. When it detects a car, for example, the DC voltage source will generate voltage and it will run through the circuit to the resistor, and then the voltage will flow through the shunt motor. The shunt motor will convert the electrical energy to mechanical energy, and the shunt motor will flow through to the wheel and axle that will generate the torque to lift our garage door. So that is basically how our circuit works. Next, we move on to the component in the circuit. First, we have DC voltage source that will generate the volt, and we have resistor that will resist some of the voltage in the circuit, and the resistor is connected to voltage sensor and current sensor. The voltage sensor is functioning to detect volt in the resistor, meanwhile current sensor function to detect the current in the circuit. And then we have the scope voltage and the scope current. Scope voltage this scope will tell us how much voltage and current respectively in the circuit. Then we have the shunt motor. Shunt motor will convert the electrical energy to mechanical energy. The shunt motor is connected to wheel and axle. Wheel and axle will generate the movement to move our garage door. And then this wheel and axle is connected to ideal torque sensor. This is a sensor that will detect the torque in our circuit. This is the result for our simulation. This is for the voltage. We have 240 volt in the circuit. For the current, we have 24 ampere. And then this is the torque that we gain in the circuit for the shunt motor. So, and all these results will be compared to the calculation in the next part.
Hello doctor, my name is Hafiz Siraj, holder of the metric number U2003951. I'll be continuing from Ahmad Aiman's presentation. I'll be talking about the calculation. So take a look at the circuit here. We will label the current that flows to the resistor with I1 and the current that will flow to the motor with I2. These are the values that we will use for this calculation. Since the circuit the current flows is parallel, so we will the voltage will be the same for each branch. And next we will calculate the resistance. Since the resistors are in parallel, we will use the 1 over R of the total is equals to the 1 over R of the resistor plus 1 over R of the motor. We will get 6 over 50 ohms. And then to calculate I1, we will use the voltage, which is 240 volts, over the R that is located near I1, so it's 10 ohms, so we'll get 24 ohms. I2, we will use the same value of the V, but we will use the resistance of the motor, which is 50 ohms. So next we will total the whole I in the circuit, so it's I1 plus I2, 28.8 amperes. So next we will be calculating the power. So P power for the current that flows onto the motor we're using the I2, so multiply it by the volt, we will get 1152 watts. And then the next one is the power that goes to the resistor of the circuit, which is we'll be using I1 in the calculation. We'll get 5760 watts, and we total the power, which is 6912 watts. And to calculate the torque of the motor, we will be using the power of the motor and then the speed of the motor. So for the power of the motor, we will be taking power of P2 because the power is current from near the motor. So the P of the motor is 1152 divided by the speed of the motor, which is 1050 RPM, and hence this is the value of the torque we will obtain from the motor.
Hello doctor, my name is Shukri Hilmi bin Samsul, metric number 17204537/2, and I will be continuing on the improvements. So in terms of improvements we can do in our circuit, we can add a weight sensor which will be connected to the motion sensor via AND gate, so that only a weight of a car and the motion can trigger the opening of the garage door. This is to ensure that no stray movements such as someone walking outside will trigger the opening of the garage door. Next, we can also add a timer to ensure that the garage door will not close immediately if the car suddenly stops midway in the garage. This is to ensure that the garage door will not damage the car if it suddenly stops. And next, we can also add an RFID tag which will be connected to an RFID module to only allow verified tags to make the garage door open. This will increase security and ensure that only wanted vehicles are in the garage. Thus, in conclusion, the electrical component used in the circuit is verified to be usable and applicable through simulations using Simulink and MATLAB. The calculation for the total voltage, total current, power input and output, motor and graph of signals are validated using MATLAB and also manual calculations. Furthermore, by using motion sensor in our smart garage door system, we could construct a circuit that will only power up the motor to open the garage door when there's vehicle approaching near the garage. Hence, our objective is achieved. That is all from us. Thank you.